Howdy folks, I'm Keith Bowen and this is Hard Rock University. Now a few lessons ago I showed you a simplified method of hand panning, and then a few lessons after that I showed you a few of the tricks for when you have like a high sulfide ore or something. But on the high sulfide ore one, I found out that some of the larger gold particles seem to be sliding down the pan while the smaller particles were still sticking up in the corner. So it's been really hot here lately. That's one reason you haven't seen much in the way of videos. And so I thought I'd go out there and take some buckets of crushed rock that I had and check them out, see what was what. And when I was done, I panned a lot of the concentrates, and I found that I had a sample that actually had particles of gold that would slide down the pan and others that would stick up in the corner. And so I spent the time to figure out what the heck was going on, and I can pretty well describe it now, although I don't necessarily understand exactly what's going on. And the gold I measured, didn't use a loupe. Loupes are fine for seeing things, not so much for measuring. I used a pocket microscope with a reticle in it. Now with the reticle, when you're looking at the object, it's just like laying a tape measure next to it. You can see exactly how long it is. And so my particle sizes are pretty accurate. What I found out was that if I was trying the swirly technique to uncover stuff, everything moved. Okay? All the gold that I had would move pretty easily with the swirly technique. So this applies to a lot of different gold that would not be recovered in a normal reveal. And when I did my reveal with the tapping technique, the larger particles were sliding down the pan, the smaller particles were staying up top, so I measured the size, and there was a clear differentiation somewhere right around 50 mesh. The 60 mesh and smaller particles were sticking up in that corner, and I mean it was down all the way to about 400 mesh. It's right at basically 1/100th of an inch. Particles smaller than that would stick up in the corner. Particles 1.5 of an inch would slide down the pan, or greater. And say, unfortunately, you couldn't like use the swirly technique to recover some and then the tapping technique to recover others, because the swirly wouldn't recover anything with any reliability. So I'm not sure exactly why it does it. I have a feeling it has to do with capillary attraction, and as such, it's very interesting and potentially useful or very unuseful depending upon what you're trying to do. In this technique, you pretty much have to just be aware of it and visually look for the larger particles at a certain step of the process to make sure you're not missing any. But now what I'm going to do is rearrange the camera and the lighting and stuff, and I'll actually pan some stuff and show you how it looks. Okay, now I'm panning into another pan because I got a very special sample here that I don't want to mess with. Where is it? There it is. As you can see, there's very little material in here, maybe, I don't know, half a teaspoon at the most. Standard procedure. Okay, here's the microfine gold, and in this area here is where I'm seeing the larger particles of gold. You can see that's a big separation, and if you didn't look before all that came down here, it'd wind up getting buried in all the sulfides. So that's where you need to pay close attention when you're getting it to the last little bit like this. Even the previous one or two iterations of the procedure, you should probably be looking pretty much everywhere. Wait when the last of the sulfides start getting down, well, actually the first of the sulfides start getting down into this corner of the pan, you need to go ahead and examine with the loupe everywhere to see if you're missing something. Larger particles of gold have a lot of material in them compared to the small ones, so if you lose just a big one single particle, that can be important. Now I'm going to try and pan some other stuff here too to see how that reacts compared to this. Try and get an idea. I don't have any gold nuggets. If I did, I'd be happy to put one of those in here, try it out. But I have a number of different things. First of all, I have a nut. Now, this is just a 1/4 inch nut, specific gravity of about 8.5, I believe. It's rather smooth surface. So I'm going to put it in here, and holding it flat, you can see it travels right to the front of the pan. Then as I tilt it and start tapping, it drifts rapidly down, even though the other material hasn't moved very much. So that was about there. As you can see, this material has only moved this far, and this is all marked. So the density doesn't appear to be nearly as important as the friction. This is a pretty smooth surface. I tried roughing up one side a little bit with some sandpaper. It didn't work. Sandpaper seems to be better at smoothing than roughing. Now, let's take, this is a regular rock. There's a little gravel right here. I just took a piece of gravel. It's pretty rough surfaced, rough texture. See how it immediately goes to the top there. And it also seems to fall faster than the higher density materials, the sulfides. This rock, on the other hand, is higher density. This rock is like hematite. Let's see how it reacts. Come on, get out of the way. And it also seems to drift downwards faster than the fine heavies. So, strangely enough, it appears that the smaller particles of gold can sometimes be easier to separate than the larger particles of gold. This affects me in some of the stuff I'm doing, especially with this assay technique, but there may be other separation techniques where this physics comes in handy. So there you have it. Sometimes fine gold is easier to recover than not so fine gold. Anyhow, happy prospecting and keep it safe out there.